Hello everyone, this tutorial is about Legendars homogeneous differential equations. Legender is basically an evolved form of Cauchy. In Cauchy we had equations in which we would have an x here and an x here, and over here it would be any function of x. But in Legender equations we have a whole term of x here and here, and this is known as we call these equations as Legendars homogeneous differential equations. So how to solve them? Well, in Cauchy we substituted x with e to the power z. Now we're going to substitute this whole term with e to the power z, and this would become equal to, if you apply the logarithm, z equals log a plus bx. Just like Cauchy, the first derivative would be equal to this, and the second would be equal to this, and third, and then so on. So let's just move on to our solved example. Here we have a question: 1 plus x whole power squared d squared y over dx square plus 1 minus x dy dx plus y equals sine 2 log 1 plus x. Wow. So we're going to take this term and going to replace it with e to the power z, or log 1 plus x equals to z. And similarly this term, then this term later on. So putting these values we get this equation: d minus 1 y plus dy plus y equals to sine 2z. Now we simplify this, so we get this. Now we need to find our yc, so we have to make our auxiliary equation, right? So our auxiliary equation becomes this. Now here we have complex roots, so our yc, or our complementary function, would be equal to this. And now we will work to find the yp. So we take 1 over the quotient multiplied by the term on the right hand side, and here we have dx d square, and whenever we have d square we replace it with minus a square. So a is 2, this becomes minus 4, and when we simplify this, this becomes 1 minus 1 over 3 sine 2z. So to find y, we add both our functions, the complementary function and our particular integral, so we get this. Now these are in the form of z, we need to get them in the form of x again. So what we do is we replace the values back, so this whole term becomes this, and this is how you solve a Legendre differential equation. Thank you.